Hello, ladies and gentlemen. Today we're going to talk about natural logs. This is a different type of log. You need your notes, that little foldable guide that you got in class, something to write with, and for sure a calculator because once again we are going to practice using our calculators to evaluate log expressions. So let's talk about where we've been. We've already talked about logs that are log logs, okay? Common logs are those that are base 10 only, and those are the ones that are programmed in your calculator. But you can adjust that formula by doing the log of something divided by the log of something. Remember that change of base? How we evaluate using the log button in our calculator. Now, natural logs are another type of log, and they have a special base. It's a base of e. So instead of writing log with a base of e, logs that have a base of e are given their own special abbreviation called natural logs. ln, for example, like you see here. So the ln, or natural log, has a base of e. See, check out all the little e's. It's sitting on the base. Get it? Get it? Okay. So it's a natural log and it has a base of e. Its abbreviation is ln. So in your notes, what is a natural log? In that little foldable, a natural logarithm is a log that has a base of e. So it's the inverse of anything that has e to the x power. We're going to use the natural log when we're solving when we have e to the x, okay? The abbreviation is ln rather than log. You won't see it with a base because we always assume those are base e. That's the only type of base a natural log can have that we're going to be using, okay? So other logs may have different bases, but a natural log will always have a base of e. You will find the ln button located on your calculator really close to the log button, okay? The regular log button for all the other bases we have, and then the ln for when we have that base of e. So let's talk about converting again. Rewriting from one form to the other. So when we have log form, or in our new case, ln form, we will see expressions that look like this. I know you love the symbols. So the natural log, or the ln, of the smiley face equals the money symbol. Now, if I were to convert that into what that means in exponential form, I would need to know who's the base, who's the exponent, and what does it equal. Now, remember, natural logs, or log natural here, has a base of e always. You won't ever see it there, but it's always there. So if I rewrite it, I would rewrite it as e to the money symbol equals a smiley face. Yay! Okay, that's kind of a weird smiley face. There we go. Okay, better. So e to the money equals smiley face. Now what about the next one? What if I have a natural log of 1 equals 0? Well, again, remember natural logs will only have that base of e, so I would rewrite it in exponential form as e to the 0 equals 1. So now what if it's already in the e form? E to the fourth is 54.6. How could I write that using a log? Well, logs that have a base of e are the natural log. So I would write ln. Don't need to write the base because it's always a base of e, but if you want to, you can write that little e down there. And then 54.6 equals 4. So we're talking about converting just like we did with the other logs. It's just that a natural log has a base of e. So how can we use this to help us solve? Remember, that's where we're going. We're working to that situation where we can solve for x no matter where he's at. So this one we need to rewrite in natural log form and then solve for x. So we have e to the x plus 1 equals 148.413. So if I rewrite it in natural log form, we'd have a natural log. Who's the base? Little e, right? We don't need to write it, but he's always assumed to be there. And then we would put the 148.413 equals, and then we would have the exponent x plus 1. Now check it out. This side is a natural log of some number, and we have a calculator that has a natural log button on it. So if I just hit natural log of 148.413 and ask my calculator, it gives me pretty much 5, 4.999999, okay? So that turns into a 5, so 5 equals x plus 1, ladies and gentlemen. That's easy to solve. Just subtract the 1 and x equals 4. but it all hinges on the fact that we can write what that means in log form. Okay, so x is 4. Let's do another one, but in reverse this time. It says rewrite the in exponential form so that we can solve for x. Right now it's the natural log of something equals 2.369. Well, I don't want to guess and check forever to solve for x. So if I rewrite what it looks like in exponential form, then maybe that'll help me get x by itself. So remember, who's the base on this log that we don't see? That's the little e. He's down there. He's the only type of base we're going to have on that natural log. So e raised up to the 2.639 equals x. So we're going to change his form. Base exponent, what does it equal? Nice. Now we can go to our calculator. You have an E button on there as well. And if you don't, you can always type in 2.72, 2.713 or whatever. We type in the E, okay? So you can type that in, but most of us have an E button in fact, or you might even have an E raised up to a power already button because it's so common. So if you type in e to the 2.639, you end up with x being really darn close to 14. In fact, you get 3.9 or 13.9999. So to 14, if we even round it at all, we get 14. I like it. There's what x equals, okay? That natural log of 14 is 2.639, okay? So that's how we can use our understanding of what these logs represent and that e to help us solve for x. But a lot of times we're just going to be typing in expressions into our calculator. So when we have to do that, how do we type these in? We need to use that natural log button. We need to be able to use parentheses and negative signs when appropriate. So let's figure out what this one says. This is saying we want to take -2 times the natural log of 4. So if you have a calculator where you can type that in all the way in your screen, you can do that, -2 times natural log of 4. Or you might need to find the natural log of 4 first and then multiply it by -2 either way. But on my calculator that I'm using, I will just type in straight across -2 times the natural log of 4, shut the parentheses. If some parentheses pop up, the only thing we're taking the natural log of is 4. And you should end up with a negative value of -2.77, okay? Now, how would we do the second one? Well, again, this is where the parenthesis feature of a nice scientific calculator comes in handy. Basically, we have 3 natural log of 5 plus 1, or you can simply do 5 plus 1 and call that 6. So this is 3 times the natural log of 6. So 3 times the natural log of a 6 gives me 5.38 if I round to the nearest 2 decimal places there, or the nearest hundredth. Let's look at the next one. Notice that this one's written a little differently. We have 1 plus 4 times the natural log of 6. This is saying we have to do order of operations here, guys. We need to first do 4 times the natural log of 6. So 4 times the natural log of 6, that's multiplication, and that comes before addition. So this is 7.17. And then if you add 1 to that, we get 8.17. So be careful when you're using your calculator. Make sure if you have a special calculator or a more advanced one where you can just type all of this in, make sure you're getting those values, okay? This one is also saying a similar feature. Be careful though. This is not saying I want the natural log of 11. Notice the parentheses up here saying we want the natural log of 6. This is saying I want -3 times the natural log of 10 and then add 1 to that answer. Versus up here with the parentheses, we were saying 5 plus 1 is 6. We want the natural log of that quantity, or these two added together. So let's be careful when we type that one in. If I do -3 times the natural log of 10, you end up with -6.9. And if I add 1 to that, I end up with a value of, I'm going to do this first part that I just said, -6.9. And if I add 1 to that, I get -5.91 approximately for my final value. Okay, so this one we have 2 things going on with a plus sign in between. We have 2 natural log of 4 plus 3 natural log of 5. So 2 natural log of 4, so 2 times the natural log of 4 would be something that you might calculate first. And that might be, that's 2.77, plus 3 natural log of 5. The 3 natural log, 3 times the natural log of 5 is 4.83. 3. And now if I add those two together, so if I go ahead and add 2.77 to that, I get a value of 7.598, so roughly 7.60 for my total value. And again, if you have a calculator where you can type this all the way in, that's great. Just be careful to include parentheses when you need to. And last but not least, this is negative natural log of 4. So negative 1 times the natural log of 4. That's negative 1.39 plus 5 natural log of 5, which is 8.05 approximately. And now if we add those two together, plus negative 1.39, we end up with a value of approximately 6.65, if you will, 4, depending on how you round. So we end up with this final value, okay? So I want you to be very proficient in typing into your calculator, as well as continuing to understand how logs are related to their exponential form. The better we can get at those two skills, the easier it's going to be for us to get through the solving piece that's coming in the future, okay? I want to thank you for taking good notes, ladies and gentlemen, and I'll be checking your foldables. See ya. Kincaid out.